Let us talk about linked list implementation in C++. Let us first consider creating a simple linked list with 3 nodes. The first node has data 10 and address of the second node. The second node has address data 20 and address of the third node. The third node has data 30 and address of the next node is null. We need to create a linked list like this, and we want to have address of the first node as a representative of the linked list. We can always represent the linked list by having the pointer to the first node in C++. Let's first get an idea how is this linked list represented in memory. We can consider our memory as array of bytes, and we can address every byte. Considering this representation, here is an example representation of our linked list in memory. In this example representation, the first node is stored at address 5000. Here we assume that every node takes 8 bytes in total, 4 bytes for integer data and 4 bytes for address. Please note that number of bytes for these data types may vary from compiler to compiler. We are assuming 4 bytes here, and under this assumption, the first node is going to take 4 bytes for data, then 4 bytes for address. So first 4 bytes value is fixed, it's 10. We want to create the first node with value 10. The next 4 bytes have value 2000, which is address of the next node in the linked list. And next node is stored at 2000 address. This again has the value of the next item as 20 in the first 4 bytes. Then it has address of the third node in the linked list, 8000. So using this address, we go to the third node, and third node is at address 8000. At this address, we have first 4 bytes as value 30, and then next 4 bytes have value null. We mark next of the last node as null to show that there is nothing after this node. Now please pause this video and try to write down a C++ program that creates a linked list with 3 nodes. Your program should mainly create 3 dynamically allocated nodes, and it should link these nodes with each other. The first node is at some address. Here in this example, I've taken the address 5000. It can be anything on your computer. And this node should have this value 10 and address of the next node. The next node is again dynamically allocated at the address which is stored in the first node. And then next node has the address of third node. And third node's next is null. Let us see the implementation now. In this implementation, we are using a structure to represent a node. We call it struct node. Why are we using a structure? We need to have mixed data types to be stored at one place. The first thing is data, and other thing is address of next node. Data type of data can be anything other than integer also. For simplicity, we have considered integer here. It is like arrays. You can have an array of characters, an array of integers, array of float, or an array of custom data type like student. Similarly, we can have linked lists of characters, integers, floats, or doubles, or a custom data type. For simplicity, we are using an integer data here. The next thing is interesting. You have a pointer next whose type is same as the type of the structure. Such structures are called self-referential structures. And the reason for having self-referential structure is simple. Every node needs to have address of the next node, and the data type of next node is same as the current node. That's why we have self-referential structure. The next thing we have in the structure is a constructor. Since we are programming in C++, we can use a constructor to initialize a node. We could write a separate function, but using a constructor is a better idea. It makes the programming better. So we have created a constructor that takes an integer value. It initializes the data with the given integer value and initializes the next as null. So this is how we represent a linked list node. We could use a class also to represent a node instead of a structure. With class representation, the length of program would increase. If we follow ideal object-oriented programming approach to represent the linked list, then we should have private data, private next pointer, and then public getters and setter methods. That would increase the length of this program. The purpose of this video is to explain linked list to the beginners. That is why we have used a structure where everything is public by default. So everything is public and the code length reduces. Now we have the main function. Inside this main function, we create the head node first. We put the data 10 into it. So when you create the head node, it creates a node like this in memory, right? And you get the address of this node in your head pointer, right? So this is what you get once you create the head node. Next thing we are doing is creating the next node, 20. When you create 20, memory is allocated, dynamic memory allocated for this, and you get address of this node in a variable temp1, right? The next thing that we are doing is we are creating the third node with value 30. So this creates a node 30 with address being given in the temp2. So we have 3 nodes which are not connected yet. Next of all these 3 nodes are null. And we have addresses of these 3 nodes in temp1, head and temp2. Head is the first node that we want to have, but the memories might be allocated in any order, right? The purpose of showing this way is head might be anywhere. They should not be in increasing order of memory or any order. They can be anywhere in memory. So now we do the linking. Head next becomes temp1 and temp1 next becomes temp2. Once you do the linking, your memory representation of these nodes changes to this, right? It could be any address value, but these are just sample values. So your head has address of the first node. Next pointer of this node is 2000. And at address 2000, we have value 20 and address of the next node. And at this address, we have value as 3000 and address of next node as null. This is how we create a linked list of 3 nodes. Here is a short implementation and cleaner implementation for creating a linked list of 3 nodes. We first create the head node, right, which allocates this memory and have pointer to the head node. Then we create the next node with value 20 and we store this next node directly into the next pointer of the head, right? Then we create the third node and we directly store into the next. So we don't need temp1 and temp2 variables. We can create a linked list of 3 nodes by just using one head variable. So this is an alternate implementation. So we have talked about a simple linked list creation. This is not the general way to create a linked list. We are going to talk about more methods for linked list creation using the functions like insert at the begin, insert at the end, insert at the given position. Using these methods, we can create a linked list of any length, and we can always access all the nodes of this linked list using the head pointer. We are going to talk about these insertion methods, these creation methods in the upcoming videos.